Have you ever looked up at the night sky and wondered, are we alone in the universe? This question has puzzled mankind for centuries and is the essence of what we call the Fermi Paradox. Named after the physicist Enrico Fermi, this paradox is the contradiction between the high probability of extraterrestrial life and the lack of contact with such civilizations. To grasp the scale of the paradox, we need to understand the concept of the observable universe. The observable universe is the part of the cosmos where light has had time to reach us since the Big Bang, about 13.8 billion years ago. It's a sphere with a radius of about 93 billion light-years, containing about 100 billion galaxies, each with 100 billion stars. Now, if we consider that most of these stars are likely to have planets orbiting them, and a portion of these planets could be in the habitable zone where conditions might be just right for life as we know it, the number of planets where life might exist reaches a staggering figure. Yet, despite these mind-boggling numbers, we haven't received any signals or signs of extraterrestrial civilizations. This is the crux of the Fermi Paradox. With so many potential places for life to exist, it seems almost impossible that we are the only intelligent beings around. Some have proposed solutions to this paradox. Perhaps life is not as common as we think, or maybe intelligent life tends to destroy itself. Others suggest that advanced civilizations are avoiding contact with us, or we simply don't recognize their signals. Yet, the paradox remains. In this vast, seemingly limitless universe filled with billions upon billions of stars and potentially habitable planets, we find ourselves asking the question over and over again. So, with all these places where life could exist, why haven't we heard anything yet? To understand this better, we need to talk about the Drake equation. The Drake equation is like a cosmic roll call for extraterrestrial civilizations. It's a mathematical formula that attempts to calculate the number of advanced civilizations that might exist in our Milky Way galaxy. Now let's break this equation down. It consists of 7 variables, each representing a step on the path to detectable alien civilizations. First, we have the rate of star formation in our galaxy, then the fraction of those stars with planetary systems. Next, the number of planets that could potentially support life per such a planetary system. Following that, we have the fraction of planets where life actually develops. Then the fraction of life that evolves into intelligent beings. After that, we consider the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. And finally, the length of time such civilizations release detectable signals into space. All these factors combined give us a rough estimate of the number of civilizations we might expect to find in our galaxy. But remember, this is an equation filled with speculation and educated guesswork. Each of these variables is a piece of a puzzle that we're still trying to solve. It's like trying to predict the outcome of a lottery. Sure, we can calculate the odds, but the actual result? That's still a mystery. The Drake equation gives us a framework to explore the factors that would need to line up for us to make contact with another civilization. However, it's important to note that the Drake equation doesn't give us any answers. It's not a magic crystal ball that reveals the location of ET. Rather, it's a tool to help us understand just how many things need to go right for us to pick up an alien radio signal. But even with this equation, we're still left wondering where all the aliens are. Perhaps the answer to the Fermi Paradox lies in what's known as the Great Filter. The Great Filter is a hypothetical concept that suggests there's a barrier which tends to prevent civilizations from colonizing the universe. It's like a cosmic checkpoint that only the luckiest or the fittest can pass. This filter could be anything: a natural disaster, a self-inflicted catastrophe, or even a technological hurdle that's too immense to overcome. Imagine the journey of life as a grand staircase. The steps represent the stages of evolution, each more complex and challenging than the last. The Great Filter is the steepest step, the one that's hardest to climb. If we can't scale it, we can't move forward. This brings us to a rather unsettling question. Are we ahead of the Great Filter, or is it still looming in our future? If it's behind us, we might be among the first few life forms in the universe to have crossed this cosmic hurdle. Our existence could be a rare and precious anomaly. But if the Great Filter is yet to come, our future might not be so bright. It means we're on a ticking clock, and the alarm could go off at any moment. Astronomer Nick Bostrom pointed out that if we ever discover evidence of life on Mars or anywhere else in the universe, it would be a bad sign. It would mean that life isn't that rare. and the great filter is probably still ahead of us. There's a sense of existential dread that comes with contemplating the great filter. It makes us realize how fragile and fleeting our existence might be. But it also highlights the importance of cherishing what we have and striving to overcome whatever obstacles might come our way. Could we be one of the lucky few to have passed this cosmic roadblock? Or are we doomed to meet our end like so many before us? The Great Filter Theory underscores the profound mystery of our existence and the vast uncharted territory that lies beyond our current understanding of the universe. Another potential solution to the Fermi Paradox is the zoo hypothesis. This intriguing theory suggests that we humans are not alone in the universe, but rather, we are being silently observed by extraterrestrial life. Imagine this, the cosmos as an expansive wilderness, and we are the inhabitants of a protected reserve, a cosmic zoo of sorts, observed from a distance but never directly interacted with. The zoo hypothesis proposes that advanced extraterrestrial civilizations are aware of our existence but have chosen not to contact us. They might be watching, studying, observing us from afar just like we humans observe animals in a zoo. Or perhaps they're allowing us to evolve naturally, without any outside interference, just as we set aside nature reserves for wildlife to flourish in their natural habitats. But why would these advanced civilizations choose to merely observe without making contact? Some possibilities include a desire to protect less advanced civilizations from the potentially harmful effects of contact, or perhaps a non-interference policy born out of respect for other life forms' autonomy and evolutionary processes. Now let's ponder over the ethical implications of this theory. If we are indeed being observed by extraterrestrial civilizations, it brings into question issues of privacy and consent. We didn't ask to be observed, did we? On the other hand, if these civilizations possess the technology to observe us without interfering in our development, could they also have the means to help us resolve some of the challenges we face, such as climate change or disease? And if so, would it be ethical for them to withhold such aid? But then again, all these are mere speculations. We have no concrete proof of such a hypothesis. It's a thought-provoking idea nonetheless, and it certainly gives us a fresh perspective on our place in the universe. Are we simply an intergalactic zoo exhibit, watched from afar but never contacted? The zoo hypothesis leaves us with this unsettling question. As we continue our search for extraterrestrial life, we can only wait and wonder. Despite these theories, the search for extraterrestrial life continues. The desire to answer the age-old question, are we alone in the universe, fuels our relentless pursuit. Our quest for extraterrestrial life has led to numerous groundbreaking projects. One such initiative is the search for extraterrestrial intelligence, better known as SETI. SETI uses the world's most sensitive radio telescopes to listen for signals from space, signals that could potentially be sent by an advanced civilization. Another exciting project is the James Webb Space Telescope. Set to be the largest and most powerful space telescope ever built, it will peer into the furthest reaches of the universe, looking for signs of alien life. By analyzing the atmosphere of distant planets, it could potentially detect biosignatures, telltale signs of life. But it's not just about finding aliens. These efforts are just as much about understanding our place in the universe. They help us refine our theories about life, its origins, and its existence elsewhere. In the process, we learn more about ourselves and our home planet. In the future, the search for extraterrestrial life will continue to evolve. New technologies like quantum computing and artificial intelligence could revolutionize our search methods. We could probe deeper into space, listen to more signals, and analyze more data than ever before. We could explore other galaxies, not just our own. We could even send unmanned probes to distant star systems, searching for signs of life firsthand. The universe is vast and full of mysteries. We may not have found extraterrestrial life yet, but that doesn't mean we'll stop looking. The search for life beyond Earth is a testament to our curiosity, our determination, and our hope for the future. So next time you look up at the night sky, remember, we're just scratching the surface of what's out there.